Hi there, welcome to our Math 70 video. In this video, we're covering section 3.4, which is known as mixture questions. So this idea of mixture means I'm going to mix two different variables. They might be concentrations of various types of liquids. They might be different types of coins. They could be different types of tickets. But in particular, they are questions where we're going to mix different types of variables, and these are all word questions. So that hopefully reminds us of our four common representations of mathematical ideas. Mixture questions start with words, and we can solve them certainly using any of these other representations. And so I'm going to solve four mixture questions. I'm going to solve using maybe pictures first, and then symbols, both substitution and elimination. And then I might have to write my own to make the numbers nice, but I'll solve one using numbers. In order to save me a cramped hand and handwriting, I'm going to share my screen on the homework, which has some of these questions, because it's easier to read them typed than it is to rewrite them all. So here's our first question. A person has a bag containing quarters and dimes. There are a total of 66 coins in the bag, and the total value of the coins is $10.65. And from these two sentences, we need to pull out information about how many quarters and how many dimes are in the bag. So take a quick minute and jot down this information, because I'm going to jump back over to my notepad, and I don't want to write the whole thing again. Suppose I could just pause the video and write it down, and so that's what I did. Slightly different, but wording, but same question. A person has a bag containing quarters and dimes. There are 66 coins and a total of $10.65. So if we're going to approach this, let's approach this using pictures. First, we need to decide on a couple variables. Well, there are quarters and dimes, and rather than using Q and D, I'm going to say X is the number of quarters and Y is the number of dimes, because I'm used to using X and Y, and frankly, I'll probably forget. The next thing we need to do is we need to build ourselves a system of equations. And we do that with the second sentence of information. There are 66 coins. Aha, that means the number of quarters plus the number of dimes had better equal 66. And there's a total of $10.65. Well, each quarter is worth 25 cents. So 0.25 times the number of quarters, that's the value of the quarters. And each dime is 10 cents, so 0.1 or 0.10 times the number of dimes is the value of the dimes, and together that has to add up to $10.65. And now I have myself two equations and two unknowns. So what I did actually in my representations, I started with words and I converted it to symbols. And now I could solve it with substitution or elimination, or with a graph, or potentially by guessing and checking with numbers, which is also a valid way to solve this sort of question. It's just slow, and you'll see that when I do another example later. But let's solve this graphically. And to do that, I'm going to hop over to Desmos. Okay, here's Desmos. And I put my two equations in there. I have x plus y equals 66. and 0.25x plus 0.1y equals 10.65. And you might say, where are the lines? Well, probably they're just not in the viewing field. So let's zoom out a little bit and see if we see them. There they are. And sure enough, they cross at a point. And that point has an x coordinate of 27 and a y coordinate of 39. So x equals 27 and y equals 39. And that means there are 27 quarters and 39 dimes. Let's double check 0.25. Let's double check. The 27 quarters plus the 39 dimes equals 66 quarters total. Great. And 0.25 times 27 plus 0.1 times 39 equals 1065. And that works too. All right, I'm going to transfer that information back to my notepad. So just drawing a sketch of what we had one line that came down like this and one line that came down like that. And that point right there was 27 comma 39, which means x equals 27 and y equals 39. So there are 27 quarters and 39 dimes. And if you ask me, that's a pretty fast and easy way to solve this question. Graphical methods are great for solving systems of two equations and two unknowns. All right, I'm going to pause the video and write down the next question, and then we'll solve that one symbolically. Okay, word is slightly different, but all the information is there. A person has dimes and nickels. There are 83 coins and $7. So we're going to solve this using substitution. And no matter what method we use, the first thing we need to do is probably convert it to the symbolic system of equations. Dimes and nickels, I'm going to let x equal dimes and y equal nickels. So x plus y should equal 83. A dime is worth 10 cents, so 0.1x. And a nickel is worth 5 cents, so 0.05y equals 7.00 or 7, right? $7. All right, so if I'm going to solve this by substitution, I pick the equation that looks easier to solve for one of the variables. To me, that's this one right there. I'm going to solve it for x. So step one is I'm going to solve x plus y equals 83 for x. So I'll subtract y from both sides, and I get x equals minus y plus 83. That's my start equation. Next step is to substitute this into the other equation. So I have 0.10 times minus y plus 83 plus 0.05 times y equals 7. And now I have to solve this one. So first, I'm going to multiply the 0.1 through. So 0.10, negative 0.10y minus 8.3, because 0.1 times 83 is 8.3, plus 0.05y equals 7. Combine my like terms, and I get negative 0.05y, because negative 0.1 plus 0.05 is negative 0.05, minus 8.3 is 7, add 8.3 to both sides, and I have minus 0.05y equals 15.3. divide both sides, oops, not by y. Divide both sides by negative 0.05. Ooh, what's going on here? Here's a good example of me noticing a mistake. I was about to divide by a negative number, which would have given me a negative number of coins, which doesn't make any sense. So when I realize that, I look back through and I say, did I make a spelling error somewhere? And I did. That's a plus 83. So that should be a plus 8.3. That should be a plus 8.3, and I better start over. Let's bring this up. Mistakes happen. I make a lot of mistakes. I never make one on purpose. But part of being a mathematician is being able to notice when you made a mistake and figure out where the mistake was. So I'm going to rewrite that equation again. There we go. And now I subtract 8.3 from both sides, which makes more sense because now I have negative 0.05y equals negative 1.3. And now if I divide by negative 0.05 on either side, and I can certainly use my calculator, nothing wrong with that, but I'm going to get y equals 26. Negative 1.3 divided by negative 0.5 is in fact 26. So I have solved for one of my variables, and now I use my starred equation to solve for the other. X equals negative y, so negative 26 plus 83. And that means X is going to equal, I believe it's 57. And my last step should be to check my two equations. So I'm going to squeeze it down here. Is it true that 57 plus 26 equals 83? It is. I mean, that's that equation right here. And is it also true that 0.10 times 57 plus 0.05 times 26 equals 7? I'll leave it to you to check that arithmetic. It is true. And I have solved this mixture problem using substitution. Okay, I'll write down another one, and then I'll solve it using elimination. Okay. A school sold $7 adult tickets and $3.50 child tickets to an event. The school sold 300 tickets total and made $1,400. How many of each ticket were sold? So again, before we do our symbolic or our graphical, we're going to need to build a system of equations. Let's let X equal the adult tickets and Y equal the child tickets. Then X plus Y should equal 300 because 300 tickets were sold. And 7X plus 3.5Y should equal 1,400 because $7 per adult ticket and $3.50 per child ticket should add up to $1,400. This isn't too bad in terms of converting, or not converting, sorry, in terms of eliminating, because I can get one of these variables to have the same coefficient pretty easily. I'm going to multiply the top line by 7, which gives me 7x plus 7y equals 2,100. And then I'm going to rewrite the second line. And then I'm going to subtract the whole second line. And that's going to eliminate my x variable. 7x minus 7x is 0x. 7y minus 3.5y, well, that's going to give me the 3.5y. And 2,100 minus 1,400 is 700. And now I have eliminated one of the variables. So my new simpler equation has just a y in it. and I solve that new equation for y, divide both sides by 3.5, and I get that y equals 200. There were 200 child tickets, and now I can pick either of the other equations to find x. I think the top equation's a little easier. X plus y means x plus 200 equals 300. Subtract 200 from both sides, and that gives me that x equals 100. So there were 100 adult tickets and 200 child tickets sold. And I encourage you to do the arithmetic to check those in both of the original equations. But I'm going to move on and do one more that involves numerical representation, or as we might more commonly refer to it, guess and check. Okay, in this example, we've got a video game. It has 215 treasure chests on the level. Gold chests are worth 105 points, and silver chests are worth 40 points. The video game developer wants the average chest value to be 79 points, so that some of them will be gold, some of them will be silver, but on average, each chest would be worth about 79 points. How many of each chest should there be? Okay. So if I have no idea where to start, maybe I don't even know how to set up the symbolic form, I could just try something. I could try X is the gold, Y is the silver, and I can build myself a little table. X, Y, and let's do average value here. So one way you might start is by saying, okay, how about 0 gold chests? Well, if you have 0 gold chests, then you must have 215 silver chests. But if they're all silver chests, then they have to be worth 40 points each. That's too low. So what if you had 0 silver chests? So then you would have 215 gold chests, but now the average chest value is too high. So maybe somewhere in the middle, what if we picked 100 gold chests? That would leave us 115 silver. And how do I figure out the average value? Well, each of those gold chests is worth 105 points. So that's like 105 points times the 100 gold chests. And each of those silver chests is worth 40 points. So that's like 40 points per silver chest times 115. And I can get my average if I divide by the total number of chests. 105 times 100, that's the value of all the gold chests. 40 times 15, that's the value of all the silver chests. 215 chests total. So I can do that division and figure out what the average chest value is. I have hopped over to Desmos. I know you can't see this. That's okay. 105 times 100 plus 40 times 115. And then I take all of that and I divide it by the total number of chests. And I get about 70.77. Well, that's good news. I'm a lot closer than I was. It's still too low, but it's not way too low. Let me just do one more, and maybe that'll give me some intuition onto actually building the formula. So let's see. What if I picked, well, I need a little bit more gold to raise that average up. So what if I picked 120 gold? That would be, well, that would be 215 minus 120, which is 95 silver. And right there, that's a clue to one of my equations. Because that means that the x plus the y had better equal 215 total. And then the average value is going to be that 105 times the 120 plus the 40 times the 95. And I divide all of that by 215. And I want that to equal 79. Let's see what it actually equals. I'm changing my numbers in Desmos. I'm getting there because now I'm at 76.72. 76.72. So I could keep increasing my number of gold chests until I targeted it. And in Desmos, that's not that hard, actually. I'm going to show you, or in any calculator, that would be possible without too much extra work. So here we are in Desmos, and you can see, and so I'll share my screen with you at this point with Desmos. Here's a calculation I did to get to 76. Actually, that was 0.27, not 0.72. A little typo there. And that's still a little low. So let me go up to 125 and 90, right? Because the 125 plus 90 still has to equal 215. I'm still a little low. Go up to 130, 95. Oh no, 85. No, see, now I overshot. I went too high. So let's back it down. Let's back it down to 129 and 86. And there it is. I found my combination. 129 gold chests, 86 silver chests will get me to an average value of $79 or points per chest. So what is that actual formula? What is my second equation? Well, my second equation says 105 times my gold chests plus 40 times my silver chests, all divided by 215, that needs to equal the 79. So I actually didn't solve it symbolically or graphically, but working through the numbers helped me get to the symbolic representation of my system of equations. All right, thanks for watching.